Hello. Today we're going to give an example on the Q computation. Okay, so Q estimate. So the example we're going to give is using water. Okay, so it's going to start at say -20. So this is -20, and this is in degrees C. Okay, so temperature in degrees C. And then here is 0. Okay. Yeah, 0. And it's going to have this latent heat right here. And it's going to stay at 0, right? And this axis here is the heat added, right? So this is the Q, right? Okay. So right here, right? So at this point, it melts, right? It's from ice to water. And then it's going to go and increase the temperature to, say, 100. So this is 100 degrees C. So at that point, start to change in phase. So it has another latent heat and changing from liquid to vapor. And after that, then it started to increase the temperature for the vapor. So let's say it go up to 120 degrees C. Okay. So we want to compute for 1 kilogram. So let's say this water, the amount of water we have here, right? The water is in there. It's the M is equal to 1 kilogram. And start at that temperature and go all the way to 120 and see how much heat is needed for this 1 kilogram. So the Q, right? So we're going to call this one here, this one here, this one here, we're going to call that one Q1, okay? Q1. So Q1 is going to be MC delta T. So that's equal to 1. And C for the ice is roughly 2100, okay? Roughly 2100. So this is the C for the water. So this is C for the ice, okay? And then times delta T. The delta T is 0 minus that, so that's equal to 20. Okay, so that's your Q1 there. And for Q2, so Q2 here is the latent heat, right? It's called latent heat. So it's used to changing phase. So it's the heat used to change phase. In this case, this is M times L, and this L, it's called heat of fusion. So we're going to call LF. So it's called heat of fusion. So that's equal to 1 times LF. And LF is equal to 333. So you can go check on the table. 333, and the unit here is kJ, and then kg. Okay, so it's going to come out to be a kJ. So if you wanted to have a j, then you want to have times 3 right there. And this 2100, the unit is, this unit here is J kilogram degree C, right? So this is already in J, so that's good. And this is in kJ, so we times 10 to the 3. And then Q3, it's going to be MC delta T again. So that's going to be 1, and C for the water. So that's 4186, right? And the unit is this one here, J kilogram degree C. And then times delta T. Delta T is 100 minus 0, so that's 100. So that will be in J, and this come out will be in J. You can see this is quite large because it's times 10 to the 3. And this one is in J. I'm changing color so you can see a little better. And then Q4. right? So Q4 is for vaporization. So Q4 is similarly equal to mLV, right? So it's 1 times LV. And LV, Q4 is 2010, 2010. So almost like this one here. So water actually has higher specific heat, but ice and vapor is a little less. So 21 and then times delta T. Oh no, this doesn't have the delta T. This is just so this one need to times 10 to the 3. Let me see. I think I'm making a mistake. This is 2260, okay? 2260. And this unit here, this LV unit here, it's same as this one here. So it's kJ over kg. That's why you have to times 10 to the 3 here. So be careful with the unit, right? So then this one will come out. This unit here is for the LV, right? So for this guy here. So then once you times 10 to the 3, this come out to be a joule again. So that's Q4. And then you have Q5, right? So Q5 is going to be MC delta T again. And this is 1. And then C is for the vapor, right? So the vapor, the C is 2010, okay? This is 2010. And the unit is this one here. It's already in joule, right? So LV, they're listed in kilojoule, right? So times that, and then times 20 degrees. So 120 minus 100, so 20 degrees, right? So then that would be in joule. So you add all them together, so the total Q, it's the summation of QI and I1 to 5, okay? And that would be in joule if we're using everything in SI unit. Okay, so that's all we have today. Thank you. See you next time. Bye-bye. Bye-bye.